In this video, I'm going to go through a worked example of how to determine whether a number is prime or not for a large-ish number. And so the two things that we really want to remember, or that are important when it comes to this process, or for making the process more efficient, is firstly, we only need to check primes. So for a number like 1061, I don't need to go through 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. I don't need to go through all of those numbers if I'm just determining primeness. And the second thing is that I only need to go up to the square root. So check up to the square root. So the square root of a number is, if we have 4 times 4, that's the same as 4 squared, and it gives 16. And then so on the other side, the square root of 16 is 4. So the square of a number, the square root of a number that we're looking at for something like 1061 is, the number that multiplies by itself to give 1061. And we can usually check this using a calculator. With a number like 1061, we would be and we'll see, we would be looking at using a calculator. We're not just using divisibility tests for this. So now, why do these rules apply? I guess it's worth reflecting on this a little bit. We only need to check primes, that's this point here, because it's related to the idea if 2 is not a factor of a number, then none of the multiples of 2 can be a factor of that number either. So for instance, for the number, say 35, we know that 2 is not a factor, which is another way of saying that there's no number 2 times something equals 35. So I don't need to check whether 4 is a factor of 35 or whether 6 is a factor of 35, because if I had, if 4 were a factor, that would mean I'd have 4 times some mystery number, let's say m equals 35. But then, because of how multiplication works, that would also mean that 2 times 2 times that number equals 35. And with multiplication, we have associativity and all those kinds of things. And so it would, essentially mean that there must be some other factor here that I could substitute in and that 2 would be a factor of. So this is something that saves us a lot of time, is that we only need to check those primes. The other important thing here is that we only need to go up to the square root. Now, why we only need to go up this far, I'll take a small number that I know is prime as an example of this. So for something like 23, so I know that 1 times 23 equals 23, so it's always going to have those factors. But if I look at other kinds of factors for the number, I'll go, check 2 times something equals 23. I'll check 3, something equals 23. And then we'll check 5 times something equals 23. And so the point here is that after I've checked 5, if none of those things are factors, then it's not going to be, there's not going to be any more that I haven't found yet. And so if we did this and we know that 2 is not a factor because it's not even, and actually the number that 2 multiplies by would be something like it's 11.5 or 11.5. For 3 times something gives 23. 3 times 7 is 21. 3 times 8 is 24. So this is like 7 point something, or some fraction added to 7. So it doesn't go in. And then 5, we know that 5 times 5, or 5 squared, equals 25. So that means it's a little bit too large, but there's nothing, 5 times would be times a little bit less than 5, but more than 4. 4 point something 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 equals 23. Now at this point, my next number that I would usually be checking is 7. But the thing is, and we saw it happen here, if 7 multiplies by something to give 23, it's going to have to be a number that's smaller than 7, or smaller than 5 even. Because 7 times 7 is 49, so that's too large. So it's going to have to be one number lower than 7. But if there is such a number, then that means that that number is also a factor, and I know, because I've gone up to 7, that I would have found it already. It would have to be one of these kinds of numbers. So when we're checking for divisibility, we're going to get to a point where, like what happened here, where when we do the, say, division, so in this case here, if we do 23 divided by 5 and we check if it's a factor, we get a number smaller than the number that we're dividing by. And so once we get to that point, we know that we've kind of exhausted our search, and we don't have to worry about continuing. So putting all those things together, let's have a good think about how we would go about this number 1061. So 1061 is my number. Now the first thing I'd usually do is check the small numbers that are divisibility tests. So I know it's not divisible by 2 because it's not even. For 3, I know using my divisibility test for 3 that 1 plus 0 plus 6 plus 1 equals 8 is not divisible by 3, so I can rule out 3 as well. I don't need to check 4, so remember, we don't need to check any of the multiples of 2, we only need to check primes. So the next one I check is 5, and it's not divisible by 5 because it doesn't end in a 5 or a 0. And at this point, I'd start checking other primes, so it does help to know kind of the list of primes that we need to check, but I wouldn't, I'd use a calculator obviously for these. So it definitely helps make this kind of process of checking larger primes easier if we know and kind of remember our prime numbers and how they proceed for those lower ones. I hope I haven't forgotten any here. And now, what do we need to go up for 1061? Well, I can check this by calculator, or I can do some kind of things in my head. I know that 30 times 30 will be 900, and I know that 40 times 40 would be 1600. So I only, need to go to something less than 40 definitely. And so the only primes after 31, 33 is not prime because it's divisible by 11, 35 no, but then I can check, so 37, but 37 I think we'll find is too big anyway, but maybe if I go up to that I know I can stop. So then I'm just going to use the calculator and check whether dividing by any of these gives me a whole number. So 1061 divided by 7, no, and we get 151 as this result. 1061 divided by 11 is my next number. No, and I get 96-ish. 1061 divided by 13, no. 1061 divided by 17 is the next prime. Nope. And we keep on going. Oh, I missed the, didn't write that one in properly. 19. Oh. 29, no. And so here we can see that we're starting to get pretty close. So remember, because 30 times 30 is 900, so 31, and I should see that at the next stage, 1061 divided by 37, so this last number that I was going to check, I'm now getting a result that's smaller than that number, which means that I've passed the square root. So going through all of those, I checked each of these numbers, 7, 11, 13, 17, 19, 23, 29, and 31, and I checked 37. It was divisible by none of those, and so I can therefore say with certainty that 1061 is prime. So, I mean, this can be a pretty quick process because we see, you know, these three numbers we're able to do pretty much almost instantly in our heads, other than the, you know, the quick add up for 3, we can check straight away. And so on a calculator, and you know, it's probably quicker on a proper old handheld calculator, I only needed to check 1, 2, 3, 4, 5, 6, 7, 8, 9-ish numbers for a number that's even as big as 1,000. So, you know, overall it's a pretty quick kind of process that we can go through, and then at the end of that all, we can say with certainty that it's prime. So you know, you can always look up on the internet to see if a number is prime or not to check, but it's worth, as a, you know, exercise, think of a number and then apply this process, practice, and then, you know, check whether you're right or not, and that you haven't missed any of the things there. Okay, good luck.